we're getting into more important stuff, and the further we go, the more interesting and complicated it will get. Okay, so today we're going to make a very important distinction in logic between deduction and induction. Let's take a look at these two arguments and try to figure out what is the difference between them. If you take a look at these two arguments, they're very similar, right? But in relation to how they support the conclusion. Just remember, that's the main thing we are looking for in an argument. What do you think is different? First argument, all philosophers like logic. Ned is a philosopher. Ned likes logic. The second argument is most like logic. Ned is a philosopher, so Ned likes logic. Both of them conclude that Ned likes logic, but what's the difference? Yeah.
Guarantees for everybody, and most is not everybody, so he could be the small percentage who doesn't.
Guarantees what for everybody? Can you be a little more precise? We're not talking about everybody, right? We are talking who is the subject of this conclusion. Subject of Ned. We are trying to establish whether Ned likes logic. You're right. In the first case, assuming our premises are true, and remember, this is what we do when we analyze arguments, because we don't know Ned. We can't possibly evaluate whether it's true that Ned is even a philosopher. Who knows? But assuming it is true that all philosophers like logic, and assuming it is true that Ned is a philosopher, is there any chance Ned doesn't like logic? Really?
Not if it's all.
Well, yeah, that's what I said, the first one. All philosophers like logic, assume that to be true. Ned is a philosopher, assume that to be true. Would it then follow with strict necessity that Ned likes logic? Yes. In the second case, the situation is a little different, right? We don't have that complete certainty. Even though, would it be reasonable to conclude that Ned likes logic?
Likely.
It seems likely. It doesn't say how many are most, but I would say most is definitely more than half. So if most philosophers like logic, and Ned is a philosopher, we have good reason to believe that Ned likes logic. But the difference is, of course, it's possible that we could be wrong, even if the first two premises are true. So this is the difference between deductive and inductive argument. The first argument is called deductive. The premises in deductive argument are intended to support the conclusion in this sense. It is guaranteed that if they are true, then the conclusion is true as well. Note the word if. Obviously, premises have to be true. But this is the intention in deductive arguments, to guarantee the conclusion. Inductive arguments, on the other hand, are different. We do not get the guarantee. It merely gives you some probability. It's probable that if the premises are true, the conclusion will also be true. So this is the difference between deduction and induction. In general, deductive argument is an argument incorporating the claim that it is impossible for the conclusion to be false, given that the premises are true. Impossible. Inductive argument, it's merely improbable. Even if premises are true, it's improbable that the conclusion is going to be false, and so it rests on probabilistic reason. on probability. So how do we know which argument is deductive, which one is inductive? Because obviously when we encounter an argument, they don't always tell us which one it is. One way, it's actually the worst way, is to look for special indicator words like probably, probable, plausible, likely. They can give you some idea. I would advise against using this way. As you will see, that's probably the worst way. The other, much better way is to look at the actual strength of the inferential link between premises and the conclusion. Because remember, in an argument, we have premise and premises which claim to support the conclusion. That's the definition of an argument. So you have one or more premises, statements, which claim to provide support for your conclusion. But what is this arrow? What is this link between them? How strong is it? That is something you can evaluate using the sense of logic, and we will do some exercises today. But there is one more way, the third way actually, the formal style of argumentation. And this can help you too. It's a shortcut. Because as you will see, to evaluate the actual strength of the inferential link requires, well, sophisticated tools, and it's generally difficult. But if you recognize a style of argumentation, and we'll go over some well-known styles of argumentation, that makes your job much easier. Okay, so let's look at some examples of all these three ways to do it. The first way, again, indicator words. You can see something like this. The meerkat is closely related to suricat. Suricat thrives on beetle larvae. Therefore, probably the meerkat thrives on beetle larvae. You see the word probably. Probably. They are not sure themselves. If they're not sure themselves whether their conclusion actually follows, sounds like inductive argument. The other example, meerkat is a member of the mongoose family. All members of the mongoose family are carnivores. Therefore, it necessarily follows that the meerkat is a carnivore. Now here we see the word necessarily, so it sounds like they are sure. They're telling you that there is no way for that to be wrong. And that is a good indicator that that could be a deductive argument. There are a few additional words which can also be helpful. Improbable, plausible, implausible, likely, unlikely, reasonable to conclude. And for deductive arguments, certainly, absolutely, definitely, and so on. But I told you not to use this. So why did I say that? Because it comes with big warning. When people make arguments, they frequently insert words like "it certainly follows" into their conclusion, even though they're making inductive argument. Why would they do that? To convince you. They want you to accept their conclusion, so they make it sound like this is a deductive argument. So even though you see words like this in an argument, that does not mean argument is deductive, and vice versa. You should use the other two methods. As you will see in some exercises, it can be very, very misleading if you actually start going with the wording. The strength of the inferential link is the best way to do it. So you should, again, the exercise is simple. You imagine premises to be true, and then see, assuming premises to be true, is there any way at all conclusion will not be true? And if there's any way for the conclusion, any possibility for a conclusion to still be false, that seems like the argument is inductive. On the other hand, with deductive arguments, if it seems like the premise is being true, leaves absolutely no way for a conclusion to be false, then the argument is deductive. Here's an example. Let's say you got this argument. All entertainers are extroverts. Stephen Colbert is an entertainer. Therefore, Stephen Colbert is an extrovert. How can we assess the strength of this inferential link? Well, let's draw our circles. Remember, we did it last time. Let's do it again. Start with a big circle. If you look at the top premise, whoever is in the second place actually is your big circle, not the first place. So extroverts would be your big circle, right? Okay, this is all the extroverts. Where would we place the smaller circle with entertainers? If all entertainers are
Inside this.
inside. Exactly. We did it already. So that would be all the entertainers. And then again, second premise tells us Stephen Colbert is an entertainer. So where are we going to put X for Stephen Colbert? Inside the small circle. And remember, we already did that, but you can see yourself that if this small X for Stephen Colbert is inside smaller circle, it would have to be inside big one. That already showed you that there's absolutely no way, assuming premises are true, conclusion will be false. And we're not questioning premises. We're not worried whether all entertainers are actually true. With the other argument here, the vast majority of entertainers are extroverts, we already cannot do the same illustration. We have to also start with extroverts, but now that vast majority of entertainers are extroverts, what does it mean? We place the second circle inside. In fact, vast majority of it should be inside. But at least a little bit has to be outside. Because we're told vast majority, not all. So then it may look something like this. This would be entertainers. And now we no longer know where to put this X. The second premise just tells us it is inside the small circle, but where exactly, we don't know. What are the chances it's here? Small, because vast majority are extroverts, but we have some small probability that it could be here or it could be here. And so that argument actually isn't that. Why do we allow that? Seems like this is where you go, right? Deductive arguments. Complete certainty. Well, unfortunately, that's not how life works. There is this famous example of black swans in philosophy. Let's imagine that you investigate in swans. You are a biologist, or I don't know, one of those scientists who investigate swans. You go into the real world, look at, I don't know, 500 swans. All of them are white. Does it mean there are no black swans? No. Okay, you keep on going. You did 5,000 swans, still all white. Are you sure now? No. Keep on going. 50 years later, you counted 5 million swans. All of them are white. Are you sure now? No. So what are you going to do? Are you going to spend your entire life counting swans? No. There will be a point when you can stop and say, okay, I counted enough of these goddamn swans. Right? I'm tired of it. How about I provisionally conclude that they're all white, and if ever a black one shows up, I will just simply adjust my theory. And that is how we do literally everything in life. Another simple example. When you were driving today to school, did you have 100% guarantee that you will not get into an accident and die? No, then why did you come? Are you crazy? Well, the simple truth is, you know the chances are very small, and the benefit of getting to school nicely and with comfort in your car are higher than, for example, taking a bus, which would probably be safer, but it will take a couple of hours, even if you get there eventually. Right? So you concluded that you'll take your chances, and you were right. That is literally everything in life. So we cannot completely rely on this type of wonderful deductive arguments, even though actually in this class we will mostly deal with deductive arguments. We'll abandon the inductive ones after a couple of lectures and then switch to deductive. But nonetheless, you should know the difference, and it is an important difference. So back to argument form stuff. Even without applying any circles and using this kind of inferential link analysis, we can easily identify deductive and inductive arguments if we recognize certain forms. So there are certain formally deductive arguments. Formally deductive arguments, which by the way, we will be dealing with a lot in this class, so you should know them very well. Now we will just start on them a little bit, but later you will see them again and again and again. So 3 types of syllogisms. Remember what syllogism is? Any argument with 2 premises and a conclusion. 3 types of syllogisms: categorical, hypothetical, and disjunctive. They are all deductive, formally deductive. Formally deductive basically means their form is such that it makes a deductive argument. There are a couple of non-formally deductive arguments. They are still deductive, but they don't have any specific formal reason for them to be deductive. We will not actually deal much with them, but you should know them nonetheless. Those are arguments based on mathematics and arguments from definition. Let's take a look at some examples. So let's start with argument based on mathematics. They will always have some sort of numbers and mathematical procedure. Here's an example. A square piece of land is 100 feet on each side. We have a square piece of land, 100 feet on each side. Therefore, it contains 10,000 square feet. Is there any chance that it's not correct? Because the procedure here is obviously you multiply 100 times 100. Any chance that's going to be 9,999? 10,001? No, it's mathematics. You may say, how do we know it's 100 by 100? Remember, we're assuming it to be true. Obviously, if there's a mistake in this calculation, if somebody measured it wrong, then the whole thing falls apart. But assuming it is true that this square piece of land is 100 by 100, it will be 10,000 square feet, and there is absolutely no chance of that being wrong because mathematics is deductive process. 2 plus 2 will always be 4. And if it is 1 morning 5, then you may want to see a psychiatrist because something's going wrong. Okay. Arguments from definition. Based on dictionary definitions, we're not going to dwell on them too much, but they may come up on some exercises, so you should know something like this. Claudia is mendacious, therefore she tells lies. If you actually Google this word or open a dictionary, you will see mendacious means somebody who tells lies. So if Claudia is mendacious, of course she tells lies because that's just what it means. If you're ever in doubt, you can Google the word just to make sure, right? So this is again deductive, but not formally deductive, because the form of this argument doesn't make it deductive. It's just the principle that if the word means the same thing as another word, then they are the same. For us, these 3 are a lot more interesting and important. They are formally deductive arguments. 3 types of syllogisms: categorical, hypothetical, and disjunctive. Goes back all the way to ancient Greece. In fact, the categorical ones are the ones Aristotle was dealing with. And because of that, the very word syllogism is a Greek word. It actually means syllogismos, means a conclusion or inference. Greeks were using it, we're still using it, but we mean slightly different thing, because for Aristotle, any argument was syllogismos. For us, of course, syllogism, like I said now, just means argument with 2 premises and 1 conclusion. So if we go back here, is this syllogism? No, there's 1 premise, right? Not 2. as simple as that. There's nothing complicated about the idea of syllogism. It's not a difficult concept. Two premises, one conclusion. Syllogism. Three premises, one conclusion, not syllogism. One premise, one conclusion, not syllogism, and so on. Okay, so categorical, hypothetical, and disjunctive. Let's take a look at that. First, categorical syllogism. Like I said, those are the ones that Aristotle was dealing with. Here's an example. All ancient forests are sources of wonder. Some ancient forests are targets of timber industry. Therefore, some sources of wonder are targets of timber industry. At this moment, the best way for you to recognize it, which actually we will later say is not a good way at all, but at least for now, you can look at the first words of each statement. If they all start with all, no, or some, that will probably be categorical syllogism, right? In any combination. So here you have all, some, doesn't have to be, can be all, no, 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 all, some, no, any combination of these three words, all, no, and some. Why do we call them categorical? They have three categories of things, if you think about it. Ancient forests, in this case, sources of wonder. Then you see the third one. What's the third one?
Sources of wonder that are targets of the timber industry.
Now that's mixing two of them together. Sources of wonder, that's one. Ancient forest, the other one, and the third one, targets of timber industry. So it says all ancient forests are sources of wonder. Some ancient forests are targets of timber industry. Some sources of wonder are targets of timber industry. So in each case, the word "are" connects to this category. But in total, we have three categories, twice in each premise and twice in the conclusion. We will deal with it more in chapter 4, which will start shortly. But for now, don't worry too much about it. Just understand that if you have this type of connection between three categories, it is deductive. The conclusion will either follow or not follow with complete certainty, just like with square piece of land being 10,000 square feet. So it doesn't have to actually follow, because in this example too, you may make a mistake by saying 90 by 100 and conclude saying 10,000. So the math is wrong, so the whole thing is wrong. Here you can also have a bad argument, which does not guarantee your conclusion, but the reasoning is such that it is deductive. It's all or nothing type of thing. It either guarantees the conclusion or it doesn't. Hypothetical syllogism. Remember last time we saw this type of a statement. If a TV network is a propaganda machine, then it misleads its viewers. What did we call this statement?
Conditional.
Conditional statement. We will see them a lot, so you should recognize them. If an argument starts with a conditional statement, or if it has more than one conditional statement there, in some cases, that would be hypothetical syllogism. Hypothetical situation. If this is the case, then this is the case. We will talk about them more, but this is an example of another deductive argument form. We can also have three conditional statements like here. If this, then this, if this, then this, therefore if this, then this. This is so-called pure hypothetical syllogism, a little bit different from the previous one, but the same idea. It starts with a conditional statement, except in another one we have just one conditional statement at the beginning. Here we have three of them. And disjunctive syllogism. What is disjunctive syllogism? It starts with this disjunction, either this or this, right? So either global warming will be arrested or hurricanes will become more intense. So if we call global warming arrested G, hurricane becoming intense H, it basically tells you G or H. And then in the next premise, it removes one of these possibilities. It says global warming will not be arrested. So it's not G. What's the conclusion then? If it's G or H, but not G? age. Any chance it's not age? Based on this form, absolutely no chance. If this is true and this is true, this has to be true. So you see that this is three forms which are deductive, and like I said, we will come back to them a lot. Talk about inductive arguments for today and for next lecture. There's some inductive arguments just so that you would know them and understand the difference. What are inductive argument forms? You should know. This is just some of them, not an exhaustive list. There could be deductive arguments which do not have one of the deductive forms, or inductive arguments which do not have one of the inductive forms. But this is the typical ones. We will go through all of them. So first, predictions about the future, arguments from analogy, inductive generalizations, arguments from authority, arguments based on science, and causal inference. Not casual, causal. For some reason, students are always tempted to call them casual. They are not casually made. The reason is it's a cause and effect, so they're causal inferences. Okay, let's go through each one in turn. Let's start with predictions. Any prediction about the future is inductive. Why? You can never be 100% sure about the future. No matter how sure you are, you cannot be. Just a simple example, can you be completely 100% sure that 5 minutes from now we will still be in this room? No, chances are very high. Probably we will be, but the alarm could go off, something could happen, we could all run out, right? God forbid, but it is a possibility. Anytime you try to predict future, no matter how sure you are, you cannot be 100% sure. Here's a simple example. Something like this. Because certain meteorological phenomena has been observed to develop over a certain region of central Missouri, a storm will occur there in 6 hours. This is what you usually see in the weather forecast, right? They tell you there will be rain, or there will not be rain, or there will be wind. Can they be 100% sure? Have you ever seen them being wrong? Yeah, just yesterday, right? They promised rain. Where is this rain? Didn't happen. They actually use statistical models to calculate that. It's not just, like magic or something. They're not making this stuff up. They're not putting tarot cards and trying to figure out. But anytime you try to predict the future, you can be wrong, and especially with the weather, because there are so many factors. And even though they do their models, they calculate all this, it's all mathematically based, but there's always a chance of it being wrong. And if you notice, they actually give you percentages. They usually tell you there's 50% possibility of rain. What does it mean? Well, 50-50. Be rain, be not rain. And so on. They could give you more, they can give you less, but honestly, it's never 100%. You cannot be 100% sure it will be raining or not raining. Depending on the region, it is more or less predictable. Like in Las Vegas, I guess 90 times out of 100, you can predict it will be sunny tomorrow because usually it is sunny tomorrow. But if you live somewhere back east, like I spent some time in Montreal, the weather is so unpredictable, nobody knows what's going to be tomorrow. They could tell you it will be raining, it's not raining. They could tell you it will not be raining, it will be raining, and so on. It's constant mess. Next, arguments from analogy. What exactly is analogy? You compare two similar things or states of affairs, and you say, well, this one is kind of like that one, therefore it is the same. Here's an example. Somebody can say, because Christina's Porsche is a great handling car, it follows that Angela's Porsche must be a great handling car. It's a real life situation, right? Your friend Christina has Porsche, and you know Christina, and you know this Porsche, you have driven it before, it's a great handling car. You hear your other friend Angela just bought a Porsche, you haven't even seen it yet. Is it reasonable to conclude it is also great handling? Yeah, it's reasonable. You could be wrong. I mean, it could be very old one, like it doesn't even drive well anymore because it's so old, but chances are it is great handling car. So we do this all the time. Sometimes when we don't know something, we know something else, we just kind of try to make this similarity or analogy between them and base some arguments on them. Generalizations. That's the third type. This is very important, actually, especially in science and what subject in CSN or other universities deals with generalizations. Does anybody know? The principle of generalization is you take a sample and generalize it to the whole group. Did anyone take statistics? No? Nobody took statistics? Well, it's required for most majors. I'm not sure about computer science, but statistics does it all the time. Call statistics based on that. Selected sample, generalized. Let's take a look at the example so you could understand why and how it is done. First example. Because 3 oranges selected from a certain crate were especially tasty and juicy, all oranges from that crate are tasty and juicy. So you have a crate of oranges. How many oranges? Well, we're not told, but let's say 10,000 oranges. You want to buy for a wholesale buyer. I don't know whether they're good. Can you taste each one of them? Make a little hole? No, that would defeat the whole purpose. Right? You'll ruin them. So what do? Huh? Eat some. Reasonable amount. Let's say you want to take 3 oranges out of this 10,000. 3 is not a lot. But can you generalize on the entire 10,000?
I guess.
The answer in statistics is yes, if you observe certain rules. The rule number 1 is what? Well, nobody took statistics and you don't know. It has to be a random sample. Random sample means you take 1 orange, then you mix them up really well. The better you mix them, the better. Then you take second, then you mix them again, and then you take third. And as small as this sample is, it actually will help you to understand what are the chances of there being bad apples. Because let's say half of them are good and half of them are bad. 5,000 good ones, 5,000 bad. Statistics tell you if you randomly take 2, chances are they're random, 1 of them will be bad. And the more you take, the higher these chances. In statistics, they will actually calculate the probability. And it's never 100% unless you taste all of them, but it grows so rapidly that you don't even need a big sample. If you take 10 of them, that will be very representative in this case. Because let's say 1,000 of them are bad. Chances that 1 of the 10 will be bad. It's most likely going to be 1. Could be less or more than 1. If half of them are bad, 5 and 5. It's amazing how it works. The statistics, they can show you the whole illustration how it works. It's all mathematics, not speculation. You don't need to try all of it. Here's another example. Because 6 out of a total of 9 members sampled from a certain labor union intended to vote for Johnson, for union president, we conclude 2/3 of the entire membership intend to vote for Johnson. So 6 out of 9. Again, we have some union. We don't know how many members it has, but let's say 10,000. And we are told that they selected 9 out of this 10,000. 6 of them said they will vote for Johnson. 3 said they will vote for somebody else. So then they conclude that 6,666 will vote for Johnson and 3,334, I guess in this case, will vote for somebody else. Can they do it? And if they follow the same rule, it has to be a random sample. But unlike oranges, with people, we will encounter multiple problems. Since you didn't take statistics, we may as well talk about it a little bit, just so that you'd know. I don't know if you will ever take statistics, or if you don't. This is important, because this is actually how they do polling for presidential elections and all sorts of other elections. Well, one thing here is how do you randomly select 9 people out of 10,000? Can you put them in a bowl and mix? No. So that is a problem because if, for example, we're talking about, well, I don't know about union, but let's say presidential elections, how many people vote in presidential elections? About 180 million people, right? They are all over the country. They have all sorts of occupations. If you just stand in front of CSN and ask, I don't know, random 100 people how they're going to vote, is this going to tell you anything about how the country is going to vote? No, because people who will be answering, great majority of them will be students around the same age. So that's not going to tell you very much about how old people are going to vote, how unemployed people are going to vote, and so on. The only way for you to randomly select a sample out of 180 million people is to somehow have some sort of computer generated way to pick people at random all over the country out of this entire pool. But that is very difficult. What they do is with the phone lines, right? They call people. But that creates a problem too, because who usually answers their phones?
No longer.
They're actually older people. The older they are, the higher the chances. They have nothing better to do, right? If you're 70 years old, you're sitting there, the phone rings, you may as well answer. And you have time to talk to them and tell them whatever. But then they find out how the old people's going to vote, which doesn't tell you very much about how the country's going to vote. Because let's face it, not every voter is over 70 years old. So that creates one problem. Several other associated problems are like oranges. Can people lie? Yeah, they can just lie to you. They can say, I'll vote for this candidate, and in fact, they will vote for somebody else. Why would they do it? Well, sometimes they may not want to tell you the truth. Maybe they're ashamed of their choice. Maybe they just don't want to admit it. Another possibility is, of course, they can change their mind. They honestly tell you, I will vote for this person. And then 2-3 days later, they watch something on TV, some commercial or something, and they find out something about this candidate which they didn't know. And then they go, whoa, I can't vote for this candidate anymore. I didn't know that, and now when I do, I'm not going to vote for it. So that's another possibility. Third possibility, many people don't realize it, but it's very problematic if people refuse to give you an answer. They just tell you, I'm not going to tell you. Yeah, because, again, let's look at the possibility of if you have a presidential election, right? Let's say you have 100 people who you're going to vote for. 50 of them gave you an answer. Out of these 50, 30 people said we will vote for Hillary Clinton, and 20 said we will vote for Donald Trump. So then you conclude that 60% of people will vote for Hillary Clinton. But 50 people did not give you an answer. They just said, go away. You crazy pollster. I don't want to tell you. Are you justified now to conclude that this is 60%? No, because who knows how these 50 are going to break. It's possible that these 50 actually are all biased and prefer one of the candidates. There could be a connection between them refusing to tell you and them voting for somebody. But you don't know who. So unless they actually give you an answer, you cannot conclude anything. But they don't have to give you an answer. They're not obligated. There's no law which makes them tell you something. They can just tell you to go away, and that's it. So that is what kind of makes this kind of calculations difficult, unlike with oranges. With oranges, we can be a lot in a lot better place to conclude whether it's a representative sample. With people, it's much more complicated. Then arguments from authority. That's another type of an argument which is inductive. And believe it or not, we use them all the time. We already mentioned it first time when I was talking about general philosophy, but now we can talk a little bit more about this. So what are the arguments from authority? For example, a person might argue that earnings for Hewlett-Packard Corporation will be up in the coming quarter because of a statement to that effect by investment counsel. Investment counselor told them the earnings will be up. They are basing their argument on their words. Can they be sure? No, of course not. We've all seen investment counselors build wrong. The question here, though, is what is your authority, how reliable your authority is? Because let's compare this to my neighbor Joe, who's a plumber, told me that the earnings for Hewlett Packard Corporation will be up. So I'm putting all my money into Hewlett Packard. Does it sound like a good argument? Probably not as good as the investment counsel. Investment counselors could be wrong, but at least they know what they're talking about. Your neighbor Joe may be a nice guy, but you may want to take it with a grain of salt and check with investment counsel, because at least they are experts in the field. So that's what happens when you have arguments from authority. The question always becomes, how good is your authority? In this class, we're not going to go any deeper into that. In critical thinking, we talk about possible fallacies here and so on, but you should keep it in mind. Of course, when you're basing something on authority, the question always is, how good is the authority? If it's somebody else's words, they can always be wrong, either misleading you deliberately or honestly making a mistake. They themselves are not sure. Another example of that, lawyer might argue that McDonough committed the murder because eyewitness testified to that effect under oath. This is what we see in courtrooms, right? McDonough committed the murder. Eyewitness tells us, I saw it with my own eyes. So eyewitness in this case is the authority, and the lawyer, in this case, I guess prosecution, bases their argument on what the eyewitness says they saw. What do you think defense would do in this situation? What are the typical strategy in the court? Yeah, and then try to do what?
Poke holes into where the eyewitness is saying. Claim that
Sorry?
they're lying.
Sorry?
Claim that the eyewitness is lying. Like poke holes in their statements.
Well, how can you do that?
Honestly, asking a lot of questions.
Yeah, the typical strategy is, well, you don't, first of all, you don't necessarily have to accuse them of lying, but you can undermine their authority by asking, for example, are you wearing glasses? And did you have glasses on that time? You're wearing them. How dark was it? How far away were you? If it was dark and you were far away, how sure can you be? Right? So, for one thing, they can undermine how sure this person is. Even if you say you saw it, can you be 100% sure? Well, if you are standing right next to this person, maybe. But if it is far enough, under bad lighting and so on, that undermines this credibility of the witness. In terms of lying, yeah, you can look for ulterior motive, right? If this person has a motive to lie, let's say they will benefit if McDonough goes to jail. Of course, then, if you have evidence that this is the case, as a defense attorney, you will present this evidence and say, wait a minute, but you will like collect an insurance if my client goes to jail, something like this, right? And that again undermines them, even though they can still say, yeah, but I'm still honestly telling you this is the truth. But it will already look a little shady. If they have personal motive to lie, the jury will probably be very suspicious about what they're saying. So this is the kinds of strategies they employ, again, to undermine the authority of the witness. And the more reliable witness is, the better authority they are, the better chances that the jury will believe them. Then arguments based on signs. What exactly is a sign? For us here, the sign is any kind of message, usually visual, produced by intelligent being. So unlike with authority, we don't know exactly who produced this message. We can only guess usually, but there is a message, visual message of some sort, which tells us something. Well, the most typical example would be a road sign, right? It says, when driving on an unfamiliar highway, one might see a sign indicating that the road makes several sharp turns 1 mile ahead. Based on this information, one might argue that the road does indeed make several sharp turns 1 mile ahead. It's one of those situations when, especially with this type of sign, if you see a sign that the road makes several sharp turns 1 mile ahead, you may wonder how can it be wrong? Can it be wrong? Is there a possibility you keep on driving and there's no turn? Straight road. Yeah, like let's speculate. What could happen? They straightened out.
Yeah.
I know they can do that, but there are easier ways to imagine that. The most likely possibility is pranksters move the sign. Pranksters, right? Can you imagine that? Well, these crazy days, people do all sorts of crazy things. Somebody just moved the sign. That's a possibility. Also, you may want to pay attention to the sign itself. How reliable is it? Is it actual commercially produced sign, or is it like handmade on a piece of paper? If it's handmade on a piece of paper, even though it may be on the road, chances are it's just a prank. When in fact, if it is a commercially produced series sign, it's more reliable. But in all of these cases, there is a possibility. Like this example, obviously, there's a very small chance. But we say road work ahead. That's the sign which typically could be wrong. How many times have you been driving? It says road work. If you're driving, there's no road work. But after, well, they already finished. They didn't start. The sign is there, but nobody's doing anything.
I like the ones in California. Like you drive sometimes and it'll say watch for falling rock. And you never see it.
Well, in this case, I don't know if the rocks like has to be constantly falling. I guess what they mean is occasionally there may be a falling rock. If they were like just raining down, then I don't think they would even let you drive.
Like, okay, keep an eye out for it, but it never happens.
But I don't know how much you can really do if it's falling, like swerve around it. Well, anyway. But the idea is road signs are an example of sign, and if you make an argument based on that, it again is inductive. So in this case, it's probable, but not 100%. Then causal inference. Causal, not causal. Causal inferences, it's when you try to argue either from cause to effect or from effect to cause. Let's see a couple of examples here. From a knowledge that a bottle of wine has been accidentally left in the freezer overnight, someone might argue that it has been frozen. So this is cause to effect, right? You know the cause. You left the bottle of wine. You got a party or something. You decided to chill it a little bit. You put it in the freezer and you forgot about it. Next morning you wake up and like, oh my God, it must be frozen. Is it 100%? Can you be completely sure it is frozen? So why may it not be frozen? It seems like the laws of physics. It's so cold there that the wine freezes. Shouldn't it be frozen? But what can go wrong, for example? Freezer could have broken. That's one possibility, right? Electricity could go. That happens sometimes too. Then you go in the morning and not only the wine is not frozen, nothing is actually frozen. Everything is defrosted overnight. So unlikely, but possible. Sometimes students say that because of the alcohol content. Well, actually, you have to have at least 40% alcohol for it not to be frozen. If alcohol is higher than 40%, it doesn't freeze. That's how you can know whether vodka is good. Russian people can tell you, if you take a bottle of good vodka and put it in the freezer, it does not freeze because it's more than 40% alcohol. But if it is cheap vodka, sometimes they are like low content, then it will freeze. Don't do it. Just an example. Anyway, another example. This one is going from effect back to cause. After tasting a piece of chicken and finding it dry and tough, one might conclude that it had been overcooked. So you go to a restaurant, they serve you a piece of chicken, you taste it, it's dry and tough. Oh my God, they must have overcooked. Again, is this the only explanation? Is there something else possible? Yeah, if you start thinking about it, for example, it could be very old chicken. Sometimes if chicken is very old, no matter how you cook it, it will be tough and dry. Just because it's already this type of a meeting. So this is an example going from a fact back to cause. You have an effect. You have the chicken which has been cooked. You try to figure out the cause of it being dry. A few further considerations. Sometimes students ask, but don't they sometimes overlap? Doesn't seem like it could be more than one form. Yeah, sometimes they do. You don't have to worry about it too much. There will be questions on this on the exam, but since it's multiple choice, you will always have clear choices in that sense. You're not going to have more than one form which is applicable and still is one of the choices. But in real life, of course, it's possible that a certain arguments would be both, for example, prediction about the future and causal inference. That could be the case simultaneously. Another thing about geometry, sometimes you may wonder, what about geometry? Is it inductive or deductive? It seems like they make an analogy between triangles. They say in this triangle, just like that triangle. No, geometry is all deductive, right? Because it's based on mathematics. So geometry is deductive, not inductive. Now, in terms of science, it's actually interesting, and it also goes all the way back to Aristotle, who the first one to make the distinction between induction and deduction. But he thought about it a little bit differently. So let's try to understand what is happening here. When you're doing a scientific discovery, what actually happens is the process is inductive. It's inductive process. Scientific discovery, here's an example. We drop bodies of various weights from various heights and measure the time it takes for them to fall, right? It's a famous experiment Galileo did. Leaning Tower of Pisa. I don't know if you guys heard about it. He was dropping objects from them and measuring time it takes for them to fall. Dropped one object, measured time, dropped another one from a different height, different weight, measured time. And then he discovered, comparing it, that the time is approximately proportionate to the square root of a distance. And then from this, you may conclude that the time required for anybody to fall is proportional to the square root of a distance through which it falls. So the process is inductive. Why? Because you are doing multiple experiments and then you are kind of comparing your results and you're looking for some similarities. But if you found a law of nature, application of this law is considered deductive. So here's an example. We want to apply Boyle's law for ideal gases to a container of gas in our laboratory. Boyle's law states that the pressure exerted by gas on the walls of a container is inversely proportional to the volume. Applying this law, we conclude that if we reduce the laboratory volume by half, the pressure will double. Anyway, it's not going to happen. No, with laws of nature, we do consider them deductive, even though it's actually a philosophical question whether they are or not. But as far as we know, they always work. So this is the difference between application and discovery of the law. However, there's an interesting thing. Going back to Aristotle, Aristotle actually did distinguish this a little bit different. To him, inductive process was going from particular to general, and deductive from general to particular. So, for example, if you have some particular cases, right, and you going from particular, this would be particular cases, to some sort of general rule, you would call it induction. On the other hand, if you have a general rule and you apply it to particular cases, Aristotle called it deduction. And you can frequently still hear the same approach, but not in logic. We have actually decided in logic that it's not the best, because what did I tell you in the beginning? How do we distinguish them? Deduction based on necessity, deduction based on probability. When we try to conclude something, if our conclusion based on probability, it's induction, inductive argument. If it's based on necessity, it's deduction. As you will see in the book, I'm not going to go there very far, but there are examples where you can go from particular to general, but it is actually based on necessary reason. They're kind of counter example, even though for the most part, this holds. If you go from particular to general, it will be inductive. And if you go from general to particular, it will be deductive. But it doesn't always hold. And the better way to distinguish them is based on necessity or based on probability. If the argument is based on necessity, it's deductive. If it's based on probability, it is inductive. But you should be aware that this difference exists because, like I said, you may even hear some other professors use this distinction. It is sometimes used.